a small part of your simple cell is where we use hydrogen as a fuel. So remember, hydrogen, this is highly flammable. Okay, this is found in fireworks. That's why you hear the pop, pop, pop sound. Okay, so in a reaction where I burn hydrogen, when I use it as a fuel, right, my H2 react with O2, give me H2O. Okay, this is the exothermic reaction. Energy is given out. Okay, with the negative sign. If you cannot remember this, please take a look at the enthalpy reactions or energy in chemical reactions video. Okay, so advantages of using hydrogen as a fuel is an efficient source of fuel. It releases a lot of energy, more than other fuels like my fossil fuel. Okay, it is renewable because I can actually break it down back into this way, and then I got hydrogen and oxygen and I can burn it back. Okay, it burns cleanly and it does not cause pollution. Okay, the disadvantages is it's difficult to transport. By now we have to know H2 is a gas. Okay, it needs to be compressed. It is highly flammable, so it needs special storage. And then electrolysis is actually quite expensive. Okay, and then it can be obtained by cracking of hydrocarbon. So organic chem, we will learn that hydrogen gas, we can actually obtain it by cracking of hydrogen carbon. So we will look at the equations that are taking place in a hydrogen fuel cell. Okay, so positive electrode is my cathode. Okay, reduction rate hat occurs at the cathode, right? This is positive electrodes because the electrons flow in. Okay, and the negative electrode is the anode, right? Because the electrons flow out. Okay, and then loose electrons is oxidation. Okay, let's look at how we write the half equations at the anode and the cathode. Okay, starting with the cathode first. Okay, my oxygen is going to form OH minus. Okay, it's going to gain electrons and form OH minus. Okay, normally I will balance the O first by putting 2 in front. Okay, after that, right, with this 2 in front, I actually have 2H. So to balance out this, I have to add H2O. Okay, after I add the H2O, now if I look at my oxygen, there's 1 here and there's 3 here. So same thing, I cannot balance. So ultimately, I have to put a 2 in front, right? After I put a 2 in front, the whole thing changed to 4 because there's 2 oxygen, 4 oxygen in total, and 4 hydrogen in total. Okay, so this part is where the overall is 4 negative, right? But overall here is all neutral, so I have to gain the electrons, right? So I will gain 4 electrons on this side. So right, this is my half equation for the reduction equation over here. So oxygen plus water gives plus 4 electrons give me 4 OH minus. Okay, and the oxidation reaction, I have my H2, right? H2 ultimately, because in this equation is supposed to form H2O, right? My H2 burn with oxygen to give me H2O. Okay, so same thing, how do I balance my H2O? I have to balance it with OH minus, my hydroxide ions. Okay, plus OH minus. Okay, after I add this, likewise, I have to balance out the H. So I double it up, and then total I will have 4H, and I have to add a 2 here. All right, so same thing. Okay, on the left side of my half equation, this is 2 negative. This part is neutral, so I have to add 2 negative. Okay, so what is happening is this part is losing electrons. This part will gain electrons. Okay, so this is my half equation. over here. Okay, so ultimately when I write a balance equation, I have to just balance out both of them. The electrons I have to balance first. This one I have to times 2. Okay, so I have to put a 2 here. This one actually becomes 4. This one becomes 4. This one becomes 4. Okay, so if I write my overall equation of these two equations, I will have O2 plus 2H2O. Here I have 4H2O. So this 2H2O can be cancelled. This 4 electrons, again, this part is cancelled. Okay, so this part, because it balances out the 2 electrons, I have 2H2O left. Okay, and then I have 2H2. It will give me this 4OH minus is cancelled on this side, right? So it will give me 2H2O. And that's where I get my overall equation of H2 plus O2 give me 2H2O. Okay, so overall reaction is the conversion of hydrogen and hydrogen and oxygen into water, and then this one will release large amount of energy, and then I will use it to use it as a battery to provide electricity. Okay, so a simple cell diagram will look like this: a hydrogen fuel cell. I put in the oxygen here, I put in the hydrogen here. Right, my oxygen is my positive electrode, my hydrogen is the negative electrode. Okay, the electrodes that I'm going to use, these are positively charged, negatively charged carbon electrode. Okay, the electrolyte that's inside the battery will be KOH, or sodium hydroxide usually. All right, so this will supply the OH minus in the equation. So which OH minus am I talking about? This one and this one. Okay, and ultimately my light bulb will light up. Okay, that's all for my simple steps.